Video we are talking about a new topic called fluid statics, and of course we'll start with fluids and then we'll talk about what do you mean by statics. Now there are three different kinds of states of matter. We know something like there are three different kinds of states of matter. We have learned them as solids, whose molecular force of attraction is very strong, so they'll have a fixed shape. Liquids, whose molecular force is comparatively less, therefore they are loose. They can occupy the shape of a container, whereas solids have a particular shape. Then we have gases. Molecular force is even weak and almost non-existent, and such that they always occupies the entire volume that is available in the container. These liquids and these gases are together are called something like fluids. When somebody say it's a fluid, they mean to say that flows. Fluid is something. What the meaning of the fluid is that flows from one place to another place. So both liquids and gases comes under the category of the fluids. And here in this video, we are talking about both liquids and gases in terms of, say, these fluids, if they are in the state of rest, if these fluids are not moving, that can be studied under a topic called something like fluid statics. Static means in the state of rest. So we'll study about fluids in the state of rest basing on things like Pascal law and so on in fluid statics. Then there is something like fluid dynamics. So we are talking about the fluid that is running, that's flowing from one place to another place like a stream of water. That's in fluid dynamics. But while we are talking about both fluid statics and fluid dynamics, the opposition to their flow is not taken into consideration. But within the fluid, there is always an opposition to the flow of the fluid that's called something like viscosity. So, if the opposition to the fluid flow is taken into consideration, the subject becomes little more even go into the depth and complicated, and we'll study that in viscosity. So, in our syllabus, we'll be talking about all of that. So, but anyway, right in this video, we are not going into a lot of things, but we are restricted to fluid statics. In fact, even we are not going into fluid statics. We are willing to study about a parameter that's relevant to all of them, but more relevant to fluid statics. That is density of a fluid. Density in general is also the same word. Density is defined as mass of the element by volume of the element. That's what you mean by density. Means what? If density is large, if somebody say density is large, mean higher mass is occupied in a lower volume, right? Mass is more and volume is less. That's a higher density means. It means what? It's highly packed element, right? And vice versa. Anyway, I want to give you a word of caution that this density doesn't depends on either mass or volume, rather it is a characteristic property. It depends on the nature of the material. It depends on nature of material. Of course, it also depends on temperature. We will talk about that little later. Now, how do you measure this density? Mass is measured in kilogram, volume is measured in meter cube. So the unit of that is either kilogram per meter cube or gram per centimeter cube, which is also called as gram per cc. What is its dimensional formula? What physical quantities that it has? We want to talk. Density, mass is capital M, volume is dimensionally cube of the length. So ml power minus 3, it has no dimensions of time. So these are all the basic terms of the density. That is the first video, first class. Would like to talk little more about the densities, right? So what happens if two liquids are combined? So what is the new density? This is a point that I would like to discuss here, right? So let us consider the problem. I can like a point, right? If two liquids of densities ρ1 and ρ2 and masses m1 and m2 are mixed, combined. What is the new density is? If that is somebody's question, how do you address that question? I would like to discuss here in this video. Yeah, let's go a little into this and try to try to find out. Yes, we know total density of any liquid can be written like total mass by total volume. But the problem here is information regarding masses is given for us, but information regarding volumes is not given for us. So we shall write the unknown information of volumes in terms of known information of densities, basing on the very definition of the density itself. We know density ρ1 can be written like mass by volume m1 by v1. It implies v1 can be written like m1 by ρ1. Similarly, volume 2 can be written like m2 by ρ2. Substituting these two values in this equation, the effective density will become m1 plus m2. In the place of v1, what we have derived is m1 by ρ1. In the place of v2, m2 by ρ2. So let's simplify this a little. That is m1 plus m2. Denominator of the denominator has a density of ρ1 and has a factor of denominator of ρ1 multiplied by ρ2. So if you simplify, it will become m1 ρ2 and m2 ρ1. So the density of the mixer has a final formula now. M1 plus M2, denominator of the denominator comes to the numerator, ρ1 ρ2 divided by M1 ρ2 and M2 ρ1. This is the formula that we can use to find the effective density of two liquids. But I just want to extend this discussion a little further. What if somebody say masses of these two liquids is also equal in the given condition? They said the masses are different and the densities are different. If the masses are same, I can write the formula for the density as m1 equal to m2 equal to m. Then m plus m ρ1 and ρ2 by m ρ2 m ρ1. M plus m is 2m. I can take m common in the denominator, ρ1 plus ρ2. So masses can be cancelled. So the effective density of the two liquids can be written as 2 ρ1 ρ2 by ρ1 plus ρ2. But be careful and remember that this is effective density only when, be careful I'm writing, only when two liquids have same masses and they are having different densities, right? That's how we can solve this a small problem. And I just want to add a little difference to the problem. What if somebody says, I'll just slightly modify the problem. If two liquids of density ρ1 and ρ2 and volumes is given for you in the problem v1 and v2 are mixed with each other, combined with each other. What's the new density? So question is slightly changed. Earlier problem it is given in terms of mass. The present problem it is given in terms of volumes. But the formula remains the same. What's the formula? Density equal to mass by volume, that is total mass by total volume. But if you observe, no term of mass is given for you. So as we know the definition of the density as mass by volume, mass can be written like density into volume. So in the place of M1, density of the first liquid and volume of the first liquid. In the place of M2, density of the second liquid and volume of the second liquid by V1 plus V2. This is entirely a different formula. Be careful, right? So when a small term changes, your formula also will change significantly. But you can put again one more condition. If these two liquids are having equal volume, what is their effective density is rho 1. Let me call it as V, rho 2 and V by V plus V. That is rho 1 plus rho 2 of V by 2V. V and V will cancel. So you will get an effective density as rho 1 plus rho 2 by 2. Altogether, this is a different formula, right? So I just had started talking about a very basic topic of density, and we have got a lot further into the subject, right? Let me just conclude in what I am saying in a minute, right? So we are talking about fluids. So our core topic is fluids. So to understand fluids, we need to know some parameters. Among them, the first parameter that we are studying is density, which is to tell you that how closely packed the given liquid or how loosely the liquid is packed, right? So to know a little more about even that density, I have taken two cases. In case one, I said something like if there are two liquids having densities and masses are known for us, and I have derived a formula, and I have also concluded if their masses are equal, this is the formula. And I have changed the formula slightly. I said something like two liquids of known density and known volumes. When they are combined, what's the new density? I have derived a formula. I have kept a condition if the volumes are equal. I got one more formula. These are all basic formulas. You need not by heart them. We just need to get, understand, and derive as and when it is required. That's it. Right? Thank you. We'll continue in the further concepts of this chapter in the coming videos. Fine.